So in this video, we're going to go over the problems that are in the Unit 1 test review. So let's describe the characteristics of the function f of x equals 4x cubed minus 1. So the best way to go about doing this problem is to actually go ahead and graph this function in Desmos. So when we graph this function in Desmos, you'll see this is the graph of the function. You can see that it is a cubic function, and notice that cubic functions have no restrictions on the domain or range. So we'd say that the domain is all real numbers from negative infinity to infinity, and the same thing with the range, right? The range includes all real numbers from negative infinity to infinity. Now let's figure out the x-intercept. The x-intercept will occur where the graph crosses the x-axis. Notice that it intersects the x-axis here at this point. If you click on it in Desmos, it'll give you the coordinates. The coordinates are 0.630. So now let's figure out the center of symmetry. So remember, on a graph of a cubic function, the center of symmetry is kind of like a turning point of the function. You can see that before this point, right? So you see here that this graph is opening down, okay? And then beyond this point, the graph is opening up. So that turning point where that happens is at 0, -1. So 0, -1 is considered to be the center of symmetry of this function. Now let's graph the function f of x is the cubed root of x plus 5 and figure out what are the minimum and maximum values on the interval from -13 to 22. So this interval gives us a whole bunch of x values, right? So what we're going to do is we're going to graph the function and using Desmos and then figure out what's going on with the function in that interval. So here's my graph of f of x is the cubed root of x plus 5. And what I'm going to do is I'm just going to draw in these lines so that you can see I'm looking at the behavior of the function between these two lines, right? Because that's x from -13 to 22. Well, the minimum and maximum, remember, is talking about the y values. So to figure out the minimum, I'm just going to basically say, well, what is the lowest point on this graph? Well, the lowest point is here, and that y value is at -2. So we would say it has a minimum of -2, and that occurs at x equals -13. The maximum value would be the highest point, right? So you can see the highest point is here, and that value there is 3. So we would say the maximum is 3 at x equals 22. Now let's find out what is the inverse of the function f of x equals 1/5 x cubed. So remember, when we're finding inverses, we're going to replace f of x with y. So we have y equals 1/5 x cubed. Now to find the inverse, we're going to switch the x and y values. So when we do that, we get x equals 1/5 y cubed. So now what we need to do is we need to get y by itself in this equation, right? Y is not by itself because we have that third power. So we're going to undo that by taking the cube root of both sides. So when we take the cube root of both sides, we get the cube root of x equals 1/5 y. So now we still need to get y by itself, but it's not by itself because it's being multiplied by 1/5. So we can undo that by multiplying both sides by the reciprocal of 1/5, which is just 5/1, which if you remember, that's 5. So I'm going to multiply both sides of the equation by 5. So that gives me 5 times the cubed root of x equals y. I can also write it using inverse function notation. So I can write it as the inverse is 5 times the cube root of x. So now let's find the inverse of the function f of x equals 3 cubed root of x plus 4. So once again, the steps are going to be the same. I replace f of x with y, so I have 3 cube root of x plus 4. So now I need to work on getting that cube root by itself. Once I've switched x and y, right? I have to switch x and y. So I have x equals 3 cube root of y plus 4. Okay, so to work on getting y by itself, I need to work on getting that cube root by itself. Well, it's not by itself because it's being multiplied by 3. So I'm going to divide both sides by 3. And when I do that, I get x over 3 equals the cube root of y plus 4. Well, now to undo that cube root, I'm going to raise both sides to the third power. So when I do that, this fraction, remember by our exponent rules, like both the numerator and denominator get raised to the third power. So I basically have x cubed over 3 cubed equals y plus 4. So if I simplify that, that's basically x cubed over, and then remember 3 cubed you can do on your calculator. Just do 3 caret 3, and that should give you 27. So you have x cubed over 27 equals y plus 4. And then we just subtract 4 from both sides in order to get y by itself. So we have x cubed over 27 minus 4 equals y. Right? We can also write it using inverse notation. F inverse of x equals x cubed over 27 minus 4. So in this problem, it says that the function f of x equals x cubed is transformed to g of x equals x plus 4 cubed minus 5. What transformations are performed from function f to function g? So the way I go about doing these problems is I look at the numbers that are being added into the equation, and then I figure out what effect they're going to have on the graph. And so this flow chart from your study guide is going to be very useful when you're solving these kind of problems. So I see that, for example, there's a plus 4, right? So I want to figure out what that's going to do to my graph. So the plus 4 is on the inside of the power, right? So it's going to be a horizontal change. It's being added. And this tells me that I have a shift left when I have a plus sign in my problem, okay? So that means it's going to be shifted left 4 units. Okay, so now I'm going to do the next new part of my problem, right? I have this minus 5. So that minus 5, okay, it's on the outside of the power. So it's a vertical change being added or subtracted. And it says shift down when k is less than 0. So I would say that this is a shift down 5 units. So that's my prediction. I'm going to say it's going to be shifted left 4 and down 5. But remember, you can graph both functions in Desmos to verify. So if I go to Desmos and I look at the graph, you can see that the transformed function is in fact shifted left 4 and down 5 units. The new function, g of x, is the one that's in green, and then f of x is the one in blue. So in number 6, it says the function f of x equals the cubed root of x is transformed to g of x equals the cubed root of x plus 3 minus 2. What transformations are performed from function f to function g? So once again, I'm going to just look at the new parts of my equation and figure out what effect they're going to have. So this plus 3, that's on the inside, right? So what is that going to do? Well, it's on the inside, so that's horizontal. It's being added or subtracted. I see a plus sign, so that means it is going to be a shift left 3. Okay, so now the next transformation. I have a minus 2. Okay, so that minus 2 is on the outside of the function. So outside means vertical change. It's being subtracted. So it's going to be a shift down because k is less than 0. So it's going to be a shift down 2. Okay, so that's what I think is going to happen. I'm going to say it's going to be shifted left 3 and down 2. But let's verify with our graph. So you can see that f of x, the original function, is in purple, and then g of x, the transformed function, is in black. It is in fact shifted left 3 and down 2 units as we predicted. So that is the correct transformations. Okay, so now let's try solving this equation. So we have 3 equals the cubed root of 5x minus 8. So this is a cube root equation. So remember, when we're working with these equations, we're solving to find x. So we need to isolate the cube root. Well, the cube root is already by itself, so we can go ahead and undo it by raising both sides to the third power, right? So we raise both sides to the third power. On the left, I'm doing 3 to the third, which on my calculator, I can do 3 and then caret 3. So that gives me 27 equals 5x minus 8. So now I just need to work on solving this equation for x. So I'm going to start off by adding 8 to both sides. So when I do that, I get 35 equals 5x. And then now I need to divide both sides by 5, which gives me 7 equals x. It's always a good idea to go back and plug in your solutions and just make sure that they're right. So we get 3 equals the cubed root of 5 times 7 minus 8. So that says 3 equals the cube root of 35 minus 8, which tells me that 3 equals the cubed root of 27. If you're wondering how to do cube roots on your calculator, remember you're going to need to click the math button. Okay, and then when you click math, a whole menu of choices will show up and you'll have to choose option number 4. You'll see it has a little cube root sign. So you'll have to do 4. And then when the little cube root shows up on your home screen, you just type 27 and then hit enter. And then it will give you the cube root of 27, which is in fact 3. Okay, so that is the correct answer. So now let's try solving the equation -5 equals the cubed root of 10x minus 5. So once again, the cube root is already isolated for us, so we're going to undo it by cubing both sides of the equation. So when we do that, once again, we have that -5. Remember, you can do it in your calculator. Just do -5 caret 3. And that should give you -125. Okay, because -5 to the third is just like -5 times -5 times -5. So that's why we end up getting a negative number. So we have -125 equals 10x minus 5. Okay, so now we just need to solve for x. So I'm going to add 5 to both sides. That gives me -120 equals 10x. And now we divide both sides by 10. And so we have -12 equals x. Okay, just to verify, let's go ahead and plug into our problem. So we have -5 equals the cube root of 10 times -12 minus 5. So we have -5 equals the cubed root of -120 minus 5. So -5 equals the cubed root of -125, which is in fact true, right? You can use your calculator to check. Okay, so it says a cube root function has a domain of x is greater than or equal to -5 and a range of y is greater than or equal to 2. What is the domain of its inverse? Okay, so remember, between a function and its inverse, okay, what do we do? Remember, what we do is we take the domain and range and we basically swap them, right? Because remember, domain is x values, range is y values. So for the inverse function, what will happen is the range of this will become the domain of the inverse, and then the domain of the original function will become the range of the inverse. So we're talking the domain of the inverse, okay? Well, the domain of the inverse is going to come from the range of the original function, okay? So it says the range is going to be y is greater than or equal to 2. So if the original range is y greater than or equal to 2, remember when we switch to inverse, that's going to become an x. So x is greater than or equal to 2 will become the domain of the inverse, okay? So just you switch the domain and range when you are creating the inverse of a function. So in this problem, it wants us to solve for x. So once again, we have a cube root equation, okay? So remember, whenever we have a cube root, we want to get that cube root by itself. So it's not by itself because there's that 4 in front. So to undo that 4, I'm going to need to divide both sides by 4. So that gives me the cube root of 2x plus 5 equals 12 divided by 4, which is 3. So now I can undo that cube root, right? I can undo it by raising both sides to the third power. So that gives me 2x plus 5 equals 3 to the third. 3 to the third is just 3 times 3 times 3, which you can see it's 9 times 3, which is 27. So that's 27. Now I just need to solve this equation for x. So I'm going to subtract 5 from both sides. So that gives me 2x equals 22. Divide both sides by 2, and I get x equals 11. So x equals 11. Remember, we always want to check our solutions because it's just a good idea to make sure that we got the right answer. So we have 2 times 11 plus 5. We're verifying that it equals 12. So we have 4 times the cubed root of 22 plus 5. So that is 4 times the cubed root of 27. And the cubed root of 27 is 3. So we have 4 times 3 equals 12, which is, in fact, correct. Okay, so x equals 11 is the correct answer. So now it gives us several different graphs, and it gives us a polynomial function, x cubed minus 8x squared plus 19x minus 12. So we have to figure out how to graph this polynomial. Well, remember the way we graph polynomials is we need to define the different characteristics of the polynomial, right? So first we need to identify the zeros. So remember, we need to use that rational roots theorem. Okay, so P over Q. And what we're going to do is we're going to look at this function and say, okay, well, what are the factors of the constant term, which is 12? And then what are the factors of the leading coefficient? Well, there's no leading coefficient here, so remember the leading coefficient is 1. Okay, so we're going to list out all the factors of 12. So those are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and then plus or minus 12. And that's all over the factors of 1. Well, the factor of 1 is just plus or minus 1. Okay, so all my possible rational roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Well, now I need to figure out how many roots that I have, right? So how many of these possible roots do I need? Notice that I have a third degree polynomial. Okay, so since it's a third degree polynomial, I need 3 roots. So 3 numbers out of this list are going to be the zeros of my function. Well, now what we need to do is we need to use synthetic division and just test out and see which of these values are roots. Okay, so I'm just going to start off with 1. So I'm going to start off with 1, and then remember to do synthetic division. I'm going to list out the coefficients of this polynomial. So I'm going to write 1, -8, 19, and -12. Right? I have no skip terms because it goes 3, 2, 1, and then 0. So I can just copy those numbers down. So I'm going to bring down 1. 1 times 1 is 1. -8 plus 1 is -7. -7 times 1 is -7. 19 plus -7 is 12. 12 times 1 is 12. And then -12 and 12 are 0. Okay? So now I have my new depressed polynomial, right? It goes down by 1 degree. So that is 1x squared minus 7x plus 12. We don't usually write those coefficients of 1, so I can just write this as x squared minus 7x plus 12. So since this is in fact true, I know that x minus 1 is one of my factors, and I know that it also has an intercept at 1, 0. Okay, so I can actually go ahead and look at these graphs and see, well, which one doesn't have an intercept at 1? Well, actually, they all have intercepts at 1, right? So I can't go ahead and eliminate anything just yet. So let's try figuring out the other intercepts. Well, to do that, I can just factor this quadratic, right? So since I have a quadratic, I can go ahead and factor it. So I'm going to look at this 12, okay? And I need 2 factors of 12. Since 12 is positive, I know I need either 2 positive or 2 negative factors. Well, my b term is negative. So I know that my factors of 12 are going to both be negative. So let's list them out. So we have 1 and 12, 2 and 6, and 3 and 4. I'm going to make them all negative and see which pair adds up to -7. Well, -1 and -12 is -13. -2 and -6 is -8. -3 and -4 is -7. So my correct combination of factors will be x minus 3 times x minus 4, right? And so remember, once we have those factors, we just set them equal to 0 to figure out where the x-intercepts are. So we have x minus 3 equals 0. So if I add 3 to both sides, that gives me x equals 3. So that means I have another x-intercept at 3, 0. And then I have x minus 4 equals 0. And if I solve that, that gives me x equals 4. So 4, 0 is another intercept. So I'm looking for a graph with intercepts of 1, 0, 3, 0, and 4, 0. So let's go ahead and see what works. Okay, so A looks good. C, you can see, has an x-intercept at 2. So C is not going to work. B has intercepts at 2 and 3. So B won't work. D has intercepts at 2 and 4. So D is not going to work either. So A is looking pretty good. Let's just double check and make sure that the y-intercept is correct, right? Because the y-intercept is another thing we can figure out. So remember, you can find the y-intercept by plugging in f of 0. So we're going to go to our equation, right? I'm just going to recopy the original polynomial. So that was f of x equals x cubed minus 8x squared plus 19x minus 12, right? So the original polynomial, and then we're just going to plug in 0. So that gives us, let's see, 0 cubed minus 8 times 0 squared plus 19 times 0 minus 12. So 0 minus 8 times 0 plus 0 minus 12 0 minus 0 plus 0 minus 12. So that means that f of 0 equals negative 12. So the y-intercept is at 0, negative 12, which you can see is in fact true when we look at this graph. You can also go ahead and test some additional points if you want to just be extra sure. But since we've already kind of eliminated everything else, A is going to be the correct answer to this problem.